This is the video notes for the Geometry Big Ideals textbook, section 4.6. Alright, in your student journal on page 120 and 121, go ahead and pause the video and fill in all the images, the points, the A, B, C, D, or the various points before the translation, dilation, reflection, or rotations occur. And then restart the video and we'll go through the 6 examples. Alright, so I've gone ahead and I've graphed A, B, C, and D on my graph right here. This is going to be the pre-image before anything has occurred. The instructions say to graph the image after the similarity transformation. So we want to do both steps of the transformation and graph the final figure. So the first change in the figure is going to be this translation, x minus 5, y minus 3. It means that it moves left 5 and down 3. So we're going to plug in our points. We're going to plug in 3 for x and 6 for y. So 3 minus 5 is negative 2. 6 minus 3 is going to be 3. Alright, let's go ahead and do that straight down. So we find A prime, B prime, C prime, and D prime, just plugging in all of our points. 2 minus 5 is negative 3, 5 minus 3 is 2, 4 minus 5 is negative 1, 3 minus 3 is 0, 5 minus 5 is 0, and 5 minus 3 is 2. So now let's go ahead and let's look at our dilation. Our dilation is with a scale factor of 3. So because that's greater than 1, that means it's an enlargement, so our figure should get larger. Just take your point and plug it in again. So you have negative 2 times 3 is negative 6, and 3 times 3 is 9. Go on down your points doing that. Negative 9, 6, negative 3, 0, and 0, 6. Just plugging in each point to multiply by 3. So now let's go ahead and let's graph these points. This is A double prime, B double prime, C double prime, and D double prime. So if we start with negative 6, 9, we just come straight over here. Negative 6, 9 is right here. So this is A double prime. Negative 9, 6 is B double prime. Negative 3, 0 is C double prime. And 0, 6 is D double prime. And then go ahead and use a straight edge so that you can get some better lines and connect your dots. And you have a figure. It's called a similarity transformation because a transformation is any combination of a reflection, a rotation, a dilation, or a translation. And it's a similarity transformation because although it's not congruent, the exact same size, it is similar to the one previously. So it moved to the left and then it moved down 3, but then it was enlarged by 3. And so that's why the shape looks somewhat different. Okay, so on this one, I've gone ahead and I have graphed R, S, and T. So let's go ahead and let's do the dilation first because it is listed first. So we take each point and we plug it into the 1/4. So 12 times 1/4 is going to be 3. 8 times 1/4 is 2. Continue on down, you have 2, 0, and you have 0, 1. Now let's go ahead and let's move into this one. This is a reflection in the y-axis, and this is the rule for it, which I found I listed our rules out here just for convenience. So we're going to keep the order of the points the same, but change the sign for the x-coordinate. So we will just flip the sign on each of these. 0 can't become negative, so it just stays 0, 1. So let's go ahead and let's graph this final figure and see what it looks like. So we have negative 3, 2, R double prime, negative 2, 0, S double prime, and 0, 1, which is T double prime. Go ahead and connect your dots, which this figure to me makes a lot of sense because if you think about it, the 1/4 dilation means it was a reduction, and so it's 1/4 the size that it was. And then it was also reflected, which is why it looks like it's slanting the opposite way because it was reflected over this line after it was shrunk down. Okay, so this is number 3. You might consider pausing the video and seeing if you can do it on your own. It's very similar to what we've been doing. So a 90-degree rotation about the origin is the rule negative yx. So we're going to go ahead and we will switch the points and then make this one change signs. So here we'll switch the points, make this change signs. We'll switch the points and make this one change signs. So now this second part is a dilation of 2/3. And once again, your scale factor is 2/3, which is less than 1, so it is going to be a reduction in size. So we plug in our x, we do 2/3 times negative 6, and we should go ahead and get negative 4. And we get 2/3 times 9, and we get 6. 2/3 times negative 3, we get negative 2. 2/3 times positive 3, we get 2, and so on. All right. So these are our points. Let's go ahead and graph them. We have negative 4, 6. So this is going to be our x double prime. And negative 2, 2 is our y double prime. And let's see here, negative 4, negative 2 is our z double prime. And once again, let's go ahead and let's connect those. And although this one, once again, it doesn't look quite as easy to figure out as the ones we've been doing, but when you think about this, here it shows the 90-degree rotation, and then because it's slightly smaller, that shows that it's 2/3 of the size that it originally was. So it was a reduction. It reduced by 33%, 1/3 of its size, so it left 2/3 of what it started with. Okay, number 4 through 6, you're taking the graph and you're trying to describe the transformation that maps the pre-image to the image. So we're trying to describe how do we get from this triangle to this triangle. So I just like to start with one that's fairly obvious. Now there are more than one right answer to basically all of these. So I'm just going to show you one way, but if you find a different way, don't hesitate to come ask me and see if it's correct. So from this triangle to this triangle, obviously I can tell that it's smaller, and if I look at this side is 2 and this is 1, whereas this side is 6 and this is 3. So I am pretty confident that it is a reduction of half because each side is half the size that it was. So for me, that's where I'm going to start. I'm going to start and I'm going to take my original L, M, and N, which my L is at the point 6, 6, and my M is at the point 0, 4, and my N is at the point 0, 6. So I'm going to take that, and I'm just going to try doing a scale factor of 1/2. So remember that the rules for scale factor are kx, ky. So for us, our scale factor is 1/2, so we're going to take 1/2 times x and 1/2 times y. So if I go ahead and do this, I'm going to have the point 3, 3, 0, 2, and 0, 3. So now, on this type of a question, you definitely want to go ahead and graph the points of where you're at so you can kind of see where to go next, because we definitely are not done yet. So now the triangle looks like it's in the right place, but it's the right shape and the right size, but it's in the wrong place. So to take this point to this point, I'm going to go to the right 1, 2, 3, 4, and down 1. So I went to the right 4, and I went down 1. And so that's the translation I did to get it there. So when I'm trying to describe it, I'm going to say I did, and you can look back at this for an example. If you look at how they listed this, they show the rule for dilation, they describe the rotation in words, and then they also, if it's a reflection in words such as about the y-axis or the x-axis, you could go ahead and write that down. So in this one, I would say it's a dilation, and I would just show xy becomes half x, half y. And then I'd say that it's also a translation, and I would say just the rule for the translation, so do x, y arrow, and then do x plus 4 and y minus 1. And that would be my answer. Okay, so on number 5 here, once again, we're going from the ABC to the A prime, B prime, C prime. So we want to see how we got there. So for me, I'm still going to start with the dilation. Many people go ahead and start with the translation or the reflection, and that's okay. I just like to see the size change first, but that's a personal preference, and it's not required for you guys. So for me, I see that this is 4 units long, and this is 4 units long, where this was 2 and this was 2. So to get from this triangle to this triangle, it doubled. So I know that the dilation was a scale factor of 2, so it's going to be 2x, 2y. So let's take the point A, which is at negative 3, 3, B, which is at negative 3, 1, and C, which is at negative 1, 1. And let's go ahead and let's see what they become after we dilate them. So I'm going to multiply by 2 and get negative 6, 6, negative 6, 2, and negative 2, 2. And if we just take a look to see what that is, I'm going to go ahead and draw that on there. So we have negative 2, 2, so that's C right there. And then I have negative 6, 2, and I have negative 6, 6. So now definitely the triangle is the right size. Now I can tell just by looking at this that it is going to be a reflection, because if you see this straight line now becomes on the right hand side of the triangle. So I know that it's reflecting. So if I look halfway between these 2 points right here, this C, that line halfway between is the y-axis. So I'm pretty confident in saying that it reflects in the y-axis or over the y-axis. You can use either terminology. So I'm going to write this out, and I am going to start with my dilation, and I'm just going to put for my answer xy, arrow, and then 2x, 2y. Now you do need to go ahead and write the actual word dilation, just like you need to write the word reflection. I want it to look just like the earlier problems in the book did. So we would say reflection, and we could say in the y-axis or over the y-axis, and that would be our answer. Okay, the last problem we're doing today is going to be this one. And so if you look at this one, once again, we're going from this bigger shape because it doesn't have the apostrophe, so it's the pre-image, to the image over here. So I'm going to go ahead and shrink this down. Looking at this, the fact that this is 1 and this is 3, that tells me that it's probably a dilation of 1/3. So let's go ahead and let's try this out. So we have Q, R, S, and T. So Q is at 0, 0. R is at 4, 3. S is at 4, 6. And T is at 0, 3. So if I go ahead and I take it with 1/3 X and 1/3 Y, if I go ahead and do that, I still have 0, 0. I now have 4/3, 1, 4/3, 2, and 0, 1, which is a little awkward, but let's go ahead and play with it and see where it gets us. 4/3 is going to be the same as 1 and 1/3. So if we go ahead and graph that, we still have 0, 0. Now we have over 4/3, so that's 1 1/3, it's about right there, up 1. Okay, and then let's see here. We are going to have over 4/3, up 2. Alright, so about right there. And we're going to have 0, 1. Alright. So we take a look at this, and let's go ahead and let's try to rotate this around. So I can tell that it's a rotation, and my guess would be right here that it is probably going to be a rotation of 90 degrees. And how I can tell that is I just take a look at one of the lines, like let's say the line from Q to R. If you look at it right here, in this line from Q to R, it makes a right angle, and that's what makes me think it's 90 degrees about the origin. So let's just try it right here. So the points become negative yx. So this is still 0, 0. This becomes negative 1, 4/3. This becomes negative 2, 4/3. And this becomes negative 1, 0. So if we look at the points, negative 1, 0 is going to be right here. 0, 0 is still at the origin. Negative 2 up 4/3. I could buy that right there, and I could buy that that's negative 1, 4/3. So I feel pretty good about this. So I'm just going to go ahead and describe my change as being a dilation. And I'm going to show the rule. I'm going to do x, y, arrow, and I'm going to do 1/3 x, 1/3 y. And then I'm going to go ahead, and I said it was a rotation. And I'm going to say it's 90 degrees about the origin. And although if we don't say, we're pretty much saying that it's counterclockwise, I'm just going to go ahead and clarify just to make sure that it's counterclockwise. Okay, so that's the end of our video notes. Please make sure to write down any questions you have. Feel free to take control of your own learning. Back up this video, pause it, repeat it as necessary, and I will see you in class.